Cool. Hi, so I'm Chintan. I'm Principal Platform Engineer at Dunelm. I've been there for about 3.5 years, and I'm going to talk about our serverless journey today. So a little bit about myself. So as I mentioned, I'm Principal Platform Engineer at Dunelm. I've been in tech for about 11 years. I spent the first half of my career across the visual effects industry and financial services as a sysadmin. I then moved over to, again, another financial services company, and then on from that to Dunelm for about 3.5 years as a platform engineer, and moved to the cloud space and more the DevOps and CI/CD side of things. In my spare time, so two of the things that I enjoy doing are cycling and yoga. Sitting behind my desk all day, I've got some back problems now, so I've started to do yoga a little bit, which is starting to help. So first of all, what were we looking to do? So a really simple mission statement. So we were looking to rewrite and re-platform the e-commerce platform using serverless technologies, adopting a microservice architecture. Sounds simple, right? Well, it's not. There's quite a lot of work from a technical perspective, but there was quite a lot of organizational change that happened as well as part of that journey. And the technical journey wasn't just what tech we were using, but how we were using that technology as well. So that was that. The business was quite bold. I think, as the previous speakers mentioned, it has got to come from the business. It's got to come from the top bottom. So the business had the appetite and the boldness to say, yes, let's do this, let's go serverless. And they were very much on board, and they were very much as part of that journey to say we were working very closely with the business to build something that worked for them, but also for our customers as well. I think a lot of people will know the benefits of serverless, but I'll just quickly mention our why. So, of course, we used to run a IBM WebSphere, run our platform on IBM WebSphere in Rackspace. It was a monolithic application running on virtual machines. It was not very scalable. It was very prone to fail. So, if one component of the architecture failed, generally the entire platform would fall over, which wasn't great. Our mean time to recovery, just being able to find out what was broken in the platform and also how to fix it, quite often took quite a long time. So our mean time to recovery was quite long. Due to the number of developers working on a single service, sometimes they trip over each other, and the deployment frequency was quite low, so we couldn't deliver value to our customer quick enough as well. And finally, we were using Jenkins at the time. Obviously, we had about 10 teams, and each team was deploying in a different way using custom Groovy, which wasn't very sustainable, which meant we had very inconsistent deployment methods, which sometimes also led to quite a few issues. So I've talked about what and why, but I haven't talked about Dunelm. So really very quick intro to Dunelm. So Dunelm is a leading home furnishings brand across the UK. We have about 179 stores now. I'm quite proud to work for Dunelm. In my 30 years being on the planet, I've shopped at Dunelm, and it's quite a privilege to now be able to be a part of their journey as well. And when you think Dunelm, you wouldn't think that they're bleeding edge, cutting edge tech, that they're at the forefront of technology. That's why I'm here today, to come tell that story. So, what is our story? So, in August 2018, we as I mentioned, the business said, let's go serverless, and they had the appetite to do that. So we actually started committing code from August 2018. Fast forward a little bit to October 2019. So we went through that entire journey of rewriting, replatforming, and we went live. Now, a little anecdote from me. I remember, so I started in August 2019, so I was a couple of months into the role, and it was go live day, and we flipped the DNS over. We've got two offices, one in Syston in Leicester and one in London, and we had these war rooms set up with everyone in person, people from QA, platform, engineering, BA, all of it, and then we had 24-hour cover as well for the go live. And we flipped the DNS, 10 minutes went by, 20 minutes went by, an hour went by, and nothing went wrong. It just went live. Everything went live completely smooth. And I think that's a huge testament to the work that we put in the preceding 16 months to kind of go live, we were doing load tests every 2 weeks for about 6 to 8 weeks before that as well, and it just went live with a breeze. And then what happened in March 2020? As all of us know, the coronavirus pandemic hit. All of our stores closed. 100% of sales were now being driven through the website, and as serverless is meant to, the serverless e-commerce platform scaled with no problems whatsoever. Again, a testament to our tech teams, but also the serverless technologies behind it and our partnership with AWS, that it just scaled with no qualms. The underlying systems did struggle a little bit, but the serverless platform, no problems whatsoever. So now the bit that you're probably all waiting for. How did we do this? So the first bit I want to talk about is the team structure. So we had traditional teams where a development team would hand over their code to a DevOps team and they deploy that. So for the rewrite, when we started that in August 2018, we first moved to component teams to quickly deliver value for an MVP version of the website. So not actually for go live, but just MVP for basic functionality. We split the e-commerce website up by browse, payment, checkout, basket. So we very quickly built up these services. But and we knew this would happen. But what we realized is that there were a lot of dependencies between those teams. So if you were trying to deliver an outcome to say a customer needs to be able to check out, actually you need the basket, the checkout, and the payment service. So there were dependencies from a development perspective, but also from working on different code bases, and it was taking too long to deliver that outcome. The coordination, so our delivery chapter, of course, doing all the organization between those teams. Also, there was an overhead, and instead of our simple unit test, there was quite a big reliance on end-to-end testing as well, because suddenly you're trying to test a journey, but you've got 3 different teams who are working on different parts of the system, which wasn't scalable for us. So what did we do? We evolved. We moved to outcome teams. What that meant is that they were more aligned to the business, and our product teams were also aligned to these squads. Instead, as I mentioned, an example, what is an outcome? For example, I want to be able to check out on Dunelm.com, and suddenly those teams were a lot more empowered to deliver that outcome, but not just from a technical perspective, but what is the business logic that goes behind that, and they were working very closely with the business stakeholders to do that. It was an uphill learning curve for our teams. They suddenly had to not just code, they had to also think about business logic. How does that work? I'm not just touching one service like browse, I'm working with several services, so they had to learn the dependencies. So there's quite an uphill battle in learning and having that cultural and that mind shift to thinking that way. And also the flip side of that, what was a benefit, is that they suddenly had the empowerment and the creativity to deliver that, and instead of going, that waterfall method of software development where you kind of get your feedback from the customer or the business stakeholder, at the end, we were working very closely with the business to get that iteratively and getting that value a lot quicker. So next, just a few architectural considerations. I'm not going into too much detail. Each one of these slides could be a talk in itself, but just a few things that we came across. So, I think some of the speakers already talked about this, but we went for a loosely coupled API-first approach, which meant that we could build functionality in services without having to worry about affecting other services. The whole point of going to a microservice architecture. The API approach also made it quite easy because we now had these cross-cutting teams where outcome teams were working with multiple services. It meant that we had developers from team A, B, and C working on the same service, but because we kept it quite simple and API first, adding new functionality was quite easy, and we could have that kind of overlap between teams on different services. And also, I think someone else mentioned as well, building for reuse. So if there were architectural patterns, they were reused as well. But also there was functionality between services that instead of having duplicate code, you're maintaining a single code base and use those components within other services as well. And finally, we breaking down those batch processes into event-driven services and components meant that it was a lot easier to troubleshoot. So it was in the building phase, but also in the troubleshooting. Instead of having these long batch processes, having a more event-driven mindset meant that it was a lot more iterative and small. We were able to build those services in smaller chunks as well. But also one of the things that was on the flip side of that is that we definitely had to keep idempotency in mind, that if a message was replayed through that microservice architecture, is it going to deliver the same outcome as the first time it went through? So that was one of the challenges that we had to overcome. So next, shifting left. I think a lot of people have probably heard that term. I think there's different interpretations, but what is Dunelm's interpretation of it? So a shift left approach involves moving several phases of the software development lifecycle earlier into that lifecycle. So from a Dunelm perspective, basically, instead of building your code, getting into production or into lower environments, and then thinking about performance, security, quality, observability, maintenance, and support, we shifted that completely left from when we were committing code, but even at the design phase as well. So, I'm the principal platform engineer, I look after the platform team, and originally this all used to come from my team, but since then we've got a performance engineering team who are looking at regular load testing, but also shifting that even further left of performance testing in the pipeline. Secondly, I'll talk about security. So we didn't have a DevSecOps function before, but that's another enablement function that comes under the platform engineering banner, who are working in building the security modules into our pipelines. And that's a cookie cutter template that we have in all of our pipelines to give our developers self-service dashboards to be able to see if there's a critical vulnerability, for example. And in quality, I could talk about quality for hours, but again, shifting that left, having them embedded in the team. Observability, so our site reliability engineers, that's a new function that we didn't have 2 years ago. They are also now embedded into the teams. And then maintenance support, for example, your Lambda runtimes, that's all kind of owned by the teams, not as a platform team. We're just helping them maintain their services rather than us owning them. So a little bit more, last slide on how Dunelm was successful. So I'm just going to bring them all up first. So deploying production-ready code into production. So what does that mean? It sounds like common sense, but if you've got Team A, Team B, and Team C all working on the same service, if developer A ships their code all the way to production, but it's not quite finished, and developer B is now rebasing off that and starting development on another story, suddenly they're trying to develop with broken code. Just because that service isn't into production, it doesn't mean that the code that you put into the main branch shouldn't be production ready. So that's something that we learned quite early on. Second of all, our observability. So we took a very much a customer first approach to monitoring. So what does that mean? So for example, if your CPU or your memory or your disk space has run out on, this is pre-serverless of course, has run out and all your alarms are going off, if you're monitoring from a customer journey perspective of the customer can still check out with no problem, no degradation to functionality or performance, all those services being at 100%, all those 100% alarms don't really matter much because the customer service has not been affected, and that's something that we've done across the board now, and is a lot more effective observability and tailored to the customer experience instead of infrastructure services. Also, we aligned our cadences across teams. So again, I could talk about delivery for an entire separate talk, but we aligned our 2-week sprints across all of our teams to be at the same time. So we were doing reviews at the same times, retros at the same times, and refinement and story mapping as well. So this is where my kind of passion comes in from a platform engineering perspective. So we built self-service capabilities. So for example, to update a CloudFormation stack or to input an SSM parameter into our AWS environments, we built bot functionality to be able to do that. So that means we had the audit trail, it was self-service, and there was not a need for us as platform engineers or SRE engineers to go and do that for our engineers. They could just do that themselves, which brought in efficiencies. Before I started, we had our serverless stacks in infrastructure as code, but our IAM roles, our databases, and a whole bunch of other stuff was not in code. So I kind of brought in that mantra of strive for 100% infrastructure as code. We all know that we can't get everything in code. Some things are manual. But if you strive for 100%, then you'll get a lot closer to it. Focus on automation. If you've got automation, you'll have a lot more consistency. It will be a lot faster to deliver the value for outcomes. And again, I go back to consistency. Consistency is key in everything, and that's a big word for me, all the way from your pipelines to parameters to the way you do observability, building quality. Consistency is key in all of those things to make sure to bring stability to your platform. So a few gotchas that we came across with serverless. So again, I'm just going to clean them all up. So there was quite a steep learning curve for our engineers. Going serverless is, as I mentioned, it's a cultural mind shift, but also a technical mind shift. You're writing code in a different way, you're deploying in a different way, and your developer experience is also going to change in the way they test and they develop. Choosing the right technology for Lambda is quite important as well. So for example, in the past we were using Scala. If we'd gone down the Scala route with Lambda, our Lambdas would be quite bloated and a lot heavier. But we chose Node instead, a lot lighter, and we've got Node across the entirety of our stack for the e-commerce platform. It's a lot more lightweight, and we've got that consistency again to make sure that developers can switch between those services as well. If they're developing a service A, B, or C, they've got kind of consistent experience. And a big one for me personally, again, the journey that I went on was when we went serverless, our compute costs compared to Docker, ECS, or virtual machines rocketed down. But what we started to notice was our CloudWatch and Datadog bill was just starting to increase. And that comes with the territory of microservices and serverless architecture, just due to the complexity that brings. Tracing is a lot harder and finding problems. So, and that we tried to decrease those, and we learned that we had to fine-tune our observability, so the amount that we were logging and the metrics that we were gathering. And then we came to a happy medium, and that was acceptable for the business. And the final two are local development isn't as mature. So for example, if you're testing a single Lambda, it's quite easy, but you can't replicate an SQS queue or an SNS topic locally. So our volatile environment suddenly became a lot more important to us. And the side effect of that was think about splitting your AWS accounts by service or platform, because suddenly if you've got all these volatile environments and you're working with cloud native services, you're going to start hitting concurrent execution rates, custom domain name limits, IAM role limits. So from the start, going with a per service or per account structure, a per service or per platform structure for your accounts, you're kind of proactively not going to face those problems. And then the final two slides are, so these are some of the technologies that we were using in the past. As you can see, I'm not going to go through all of them, but you've got your platform services, your CI/CD platforms, observability, CDN, lots of things. So a big part of our journey was actually consolidating on our tools and our partners that we were working with. So I'm just going to quickly, whistle-top store, talk through them. So obviously the main one, the first one, our journey started with AWS. We were quite early adopters of serverless. I think, I'm going to get this wrong, but I think we're the biggest user of serverless in retail in Europe back then, and we still are now. We have a very close relationship with them. So it wasn't just, I think a few people have mentioned today, they're not just a vendor, they're very much a partner. For all the way from ways of working, but we were feeding back into their product lifecycle to make sure that they were delivering the things that we needed to be able to deliver Dunelm.com. Second of all, Datadog. So we had several observability platforms for our EC2, Docker, all the way to our serverless monitoring. We consolidated that all into Datadog just to have a single pane of glass. So we had full observability for end-to-end from a customer hitting pay all the way to what that means for their payment being processed in the back end. And Datadog's been a big part of that. Thirdly is Fastly. So I didn't realize how powerful the CDN actually is. Before that, we were with Instart, and we had to move away from them for several reasons. But our journey with Fastly has been great because, first of all, it's increased our site speed quite a bit, and there's a case study out there for that. But just by putting that cache on the front end, our site speed rocketed, and as a lot of you will know, lower site speed equals more money coming in. We had a lot more observability of what we were doing with our WAF. In the past, we didn't have that, so what was being blocked, what wasn't. When those attacks were happening, we had active alerts. And the biggest win for me was having 100% infrastructure as code coverage of our CDN configuration. It just meant that we felt a lot safer releasing changes to our CDN, which in the past we didn't have that confidence. And then just having that auditability and that MR process and all the good stuff that we get from Git around our CDN configuration was quite powerful. And again, these are just a highlight of the partners that we have, but GitLab has been a huge part of our journey as well. We used to be a Jenkins shop. I can proudly say we've turned off Jenkins in December 2022. We have no more Jenkins, just GitLab. So we consolidated our code repositories and our CI/CD pipelines into GitLab. We built our own modular pipeline libraries, which are used by all of our tech teams to deploy our services consistently. And since then, we've also implemented all the security stages into that shared pipeline libraries to shift that further left into the teams as well. And then finally, just the two deployment tools that we use. So we use serverless CLI with CloudFormation templates for our serverless deployments, and that's all self-service and by our product teams. They look after their own stacks. They build the stacks, they deploy them, and they troubleshoot them themselves with our enablement. And then within the platform, SRE, and data space, we're using Terraform a lot more heavily, just as our preferred tool of choice. And it's just a case of the right tool for the right job. And that's everything from me. So thank you for listening. And just a cheeky plug for me on our engineering blog that went live last year. We put a post out every Wednesday morning. So please scan the QR code to see what we're up to. Thank you very much.